This is the ECE 561 Slabcast for our project. Our project name is Programmable Quadcopter with Multitask System. This is Yu Sun. Our team has 3 members. I'm responsible for whole project design, main paperwork, and electrical piano system. The idea of this project is come from the movies and games that drones have intelligence and can do lots of amazing work. Our main aircraft is a small mini quadcopter which have both flex motion and space, and also portability as fit for daily jobs and is relatively cheap. We are planning to assign the quadcopter to have some interesting usages like playing piano with the program, the motion, and home security supervision, which can reach certain locations and send back data for future usages. Besides, we designed a GUI debugger based on MATLAB assessing the whole system control. In the meanwhile, the GUI program is also the center of all systems data. It's a prototype managed program for users to gain better performance and experience with the whole system.
Hi, I'm Yingjie. In this project, I mainly focus on 3 main parts. The first part is the quadcopter flying control software. The next is building MATLAB GUI from. The third is the home security monitor system. The control chip of this quadcopter, we use ATmE GA328P, which we can use Arduino for each developed environment, and the motion tracking sensor is MPU 6050. It is a very powerful sensor chip, which it includes acceleration and gyroscope. This sensor used to support 3 coordinate axis acceleration and angular velocity, so for mini quadcopter and GUI. And the communication models, we use Bluetooth serials to communication with the GUI. For many quadcopters flying control software, I learned and modified the multi-wings and use it to control these many quadcopters. Multi-wing is an open source control software that used in different kinds of the model aircraft. Then we can use each app to control these quadcopters. The second part is learning and building the MATLAB GUI forms and build a new communication protocols. In the GUI forms, it includes several functions. The first function is control plans, and the second function is flying tracking planning. The third function is PID setting and reading. The fourth function is display status of the quadcopters. The last function is home security monitors. And the communication protocols, it supports a software for GUI and control and monitor the status of the mini quadcopters.
Hello, my name is Chang Cui. In this project, I made a MATLAB GUI panel for controlling, monitoring, and debugging quadcopter through wired serial port first, and later through Bluetooth, which is most crucial part of GUI and also responsible for paperwork. I researched copter rotation algorithm like quaternion method, calculating moving distance, and drawing 2D picture for essential data and 3D picture for copter motion. With wired serial port, the copter cannot fly. In this part, I clicked Open Failure X button to establish communication. I periodically sent 1 byte message and received 6 data, which is pitch, yaw, roll, speed, and acceleration for axis X, Y, Z from copter. I calculated copter's rotated angles and moving distance using this data with quaternion method. The below pictures are graphs of pitch, yaw, and roll speed and XYZ acceleration. I also drew a 3D picture for checking this copter's motion. When I want to monitor flying copter, I firstly connected the copter and MATLAB panel with wireless Bluetooth. I clicked Start Fly to make copter ready for flying. I put throttle, pitch, yaw, and roll value into copter to control it fly. Because of Bluetooth's low data receiving rate, I am not able to draw 3D picture for the flying copter's motion well. Speeding up Bluetooth communication rate is one big problem for us. If we can get data through Bluetooth quickly as serial port, under this tracking picture, we are able to monitor the path of copter and send appropriate roll, pitch, yaw to make copter fly to one point, which we hope this copter to arrive at.
For the third part is the home security systems. In these systems, it includes three main sensors: the hail sensor, smoking sensor, and the shaking sensors. Hail sensors can be used to monitor the status of the windows or door. If one of windows or door is open, the GUI will make running. And the smoking sensor can use to monitor the gas, smoke, and alcohols. Shaking sensor can be used to put on the door to monitor somebody else knock the door. In this system, I use the two main MCU. The first MCU used to monitor the sensors. If one sensor detect environmental changes, this MCU will use wireless modem to connect with second MCU and send data. When the second MCU receives the data, it will use the serials to send the information to the GUI, and the GUI home security platforms will make runnings, and the GUI will plan track and send it to the quadcopters by the Bluetooth. The quadcopters will fly from the set direction and check about that.
This is Yu, and this is the part of electrical piano. The electrical piano is based on STM-A single chip system. The idea of electrical piano is to simulate real piano using Hall effect sensors. The frequency of each tones refers to real standards of tones, and I built 7 basic keys to play the scale of a tone field and offer 3 keys to shift the tone field range. The piano system is fit for both user and quadcopters to play, with lots of fun and possible future innovations and development for writing and drawing. And the future goals of our project is that we can apply multiple quadcopters to share information and do parallel tasks, and consider the short battery life of the quadcopter, some automatic recharging mechanism, and possible wireless charging technology can be developed. Besides, with future development of the task systems, personal guard application will be a good choice, and some recording missions can be assigned to the quadcopter without manual control. Thanks.
Thanks.